Alright, problem number 21. Look at the diagram below. When the door handle is pushed down to open the door, it makes a 45-degree angle with its firm position. What's the approximate arc length of the path traveled by the outside of the door? So I want this piece right here. And I know that my radius is 5.5 inches. So I'm going to use 45 over 360 to measure the angle over 360 to get what part of this circle, because ideally, since this is spinning off of that point, if I were to be able to turn this all the way around, it would make a circle. So that's where the 360 comes from. I only want 45 out of that 360. And I'm looking at length, so that tells me I'm going to use circumference. So it's 2 times pi times the radius. All right, so 45. Put that in the calculator. 45 over 360 times 2 times pi times 5.5 for my radius. Comes out to be 4.32 if I round that, which is answer choice C. Okay. Next question, number 22. The side of the intersection of a plane of a cone is modeled below. Okay. So which of the following best describes the shape formed by this intersection? Alright, so because I am looking at the base of the cone, and I know that a cone has a circular base, and this plane is cutting what looks like parallel to the base, it's going to be a circle. Now, it doesn't specifically say that it's parallel, but even if it were slanted, it would make some type of ellipse or circular pattern shape. So I know it can't be a triangle, can't be a square, and it can't be a trapezoid. For number 23, the angle of depression from a helicopter hovering 15 meters above its launching pad and to the base is 41 degrees. We want the distance from the landing pad to the tree. So we want this distance here. Because it's an angle of depression, I'm going to use this 41 degrees, but I need to transfer that 41 down here so that I can use this right triangle. And I know these are going to be parallel, so I know that those would be congruent because there'd be alternate interior angles, which means I need to use my trig function. So from the 41, this is going to be the opposite side, and this is the adjacent side. So that means I'm going to use my tangent. So now the tangent of 41 is equal to the opposite over the adjacent. Right? And because I'm solving for the x and the x is on the bottom, when I do the algebra and I rearrange all of this stuff, I'm going to end up getting 15 over the tangent of 41. Right, so I'm going to kind of skip all that part and trust that you can do the algebra. And then make sure that your calculator is set to degrees, and then we want to do 15 divided by the tangent of 41. And we get that this is going to be about 17.25 or 26. And closest to that distance is 17, so that would be B. 24, if you're given the facts that PQ is a radius of circle P, so I'm going to go ahead and draw that. P to Q. And QR is tangent to circle P. Which of the following must be a statement in an indirect proof that PQR is a right triangle? Right, so PQ is not a radius of circle P. QR is not a tangent to circle P. Triangle PQR is not a right triangle. Triangle PQR is an isosceles triangle. An indirect proof is kind of also called a proof by contradiction, and that's where you're taking what you want to prove and you want to do the opposite of that. So this is what I'm trying to show. So because I want an indirect proof, I want to say that triangle, or my assumption is going to be triangle PQR is not a right triangle. Okay, so again, kind of summarize, indirect proof, you got to take what you're trying to show and you want to assume the opposite or the negation of that. So because you want to show that it's a right triangle, you assume that it's not a right triangle. These are not it because I'm taking these definitions and I'm changing the definitions. That's not what you want to do in an indirect proof. All right, looking at number 25, what's the equation of a line that passes through 4, 6 and is parallel? So it's got to go through this point and it's got to be parallel. If it's parallel, that means it has to have the same slope. So looking at these answer choices, I know for sure I can cross out C and D. Now we could put this in the calculator and try to do some other stuff with it. The easiest thing to do is, since this is your x, y values right here, you want to plug them into here. So if this function works, I can put 4 in for x, and I'm supposed to get 6 as my answer. If I get 6 as my answer, this is the right choice. So let's do negative 3 over 4 times 4 minus 3. All right, this comes out to be actually negative 6. So more than likely A is not right. Could be that I did something wrong. So I'm not going to cross it out just yet. I always want to check the other one just to make sure I didn't do something wrong. So again, we're going to do negative 3/4 times 4. This time we're going to do plus 9. And on this one, when I do this, I do get a positive 6. So this one did not work. This one does. So B is my right answer. All right. Now let's look at number 26. Okay, I have a 90 and a 45 and 45. All right, so this is x, x, and this is going to be x square root of 2. So I want to set these two equal to each other. Divide by the square root of 2. Okay, now we can have a square root in the denominator. We got to rationalize this, so we're going to have to put square root of 2 times square root of 2, because this forces a pair of 2's in the bottom. So this ends up being 5 square root of 2 over 2 as an answer. All right. Next problem. The following conditional statement: if a parallelogram has 4 congruent sides, then it's a rhombus. Which statement is false? If a parallelogram is a rhombus, then it has 4 congruent sides. That would be true. If a parallelogram is not a rhombus, then it has 4 congruent sides. All right. C, if a parallelogram is not a rhombus, then it does not have 4 congruent sides. D, if a parallelogram does not have 4 congruent sides, then it is not a rhombus. Okay. This one's true, so I can mark that out. B, if a parallelogram is not a rhombus, then it has 4 congruent sides. This one would be the one that's false, because the other option would be a square, but a square is a rhombus. So any rhombus is going to have, or if it's not a rhombus, then it cannot have 4 congruent sides. So this statement would be false. All right, number 28 is asking for the volume of a cone. And let's see, I know the radius is 8, the height is 17. Volume is equal to 1/3 area of the base times the height. So I got 1/3 times pi times 8 squared times 17. It says round to the nearest tenth, so I want to go ahead and put pi into the calculator. So I'm going to do 64 times 17 divided by 3 comes out to be about 1,139.4 cubic centimeters.